Hello, this is Amr. I'm going to discuss microservices-based systems visualization. So, what are microservices? It's an approach to software architecture that builds a large and complex application from multiple small components. These microservices communicate together through web APIs or messaging queue to send specific events. However, this architecture is challenging, specifically for systems that provide large number of services. So addressing the challenges require consider both static and dynamic analysis. So to define the problem, let's put a spotlight on a practical challenge that happens when an error or unexpected behavior is occurred on the system. This requires a sequence of actions as following. Starting with figuring out the dynamic behavior through the system logs and tracing data. After that, getting back to the services documentation that should describe the accused microservice and its dependencies, and matching the dynamic behavior with the static documentation, which could be outdated and that require the developer to check the source code as well. After that, whether catching or guessing the failed scenario, he needs to simulate and reproduce the bug to make sure of the scenario and the fix as well. That requires engineers to understand what happened across the entire service graph at the time of the debugging. That could be feasible in small systems, but was a pain for the large ones. For example, Amazon.com calls between 100 to 150 web services to build a page, as well as Netflix microservice architecture supports about 5 billion services calls per day. This scenario and the researchers concluded that one of the most painful challenges in the microservice industry is the no system-centric view, and one way to address this is to use the system itself as living documentation and consequently visualize it in a tailored and detailed way to show all the required information. We have set of related work such as notation-based UML like communication diagram and class diagram, in addition to enterprise architecture modeling as Archimat and also metaphor modeling like CD and Island, in addition to the graph representation, which is strongly involved as a solution such as the Amazon X-ray and the Netflix architecture as well, but none showed a complete solution considering a way for navigation and traceability through different detail levels. Therefore, a novel approach is needed to face these challenges in a tailored way for microservice nature. So the proposed approach involves augmented reality in context, which has multiple benefits, either for providing a limitless rendering space or for supporting collaborative activities, which are essential for system analysis practices. This approach avoids a one-size-fits-all visualization, and it has some concepts as well that is built on top of it, which are user-centric, context-aware, interactive, mobile-based augmented reality, and it has influence from geographical map as well. Introducing the design elements, node is either service or controller. The controller is a set of services that have the same base routing. Node as well has color and size. The size is calculated using x bar y equation. X is the number of dependent node to this one, and y is the number of node that this node depends on, which means that node is getting larger when it has more number of dependencies. And the second element is the edge, which represents the dependencies between nodes. It has two types, either unidirectional or bidirectional. For the small cross lines, they indicate the number of participated services in this dependency relationship. This concept provides three architectural levels, starting with system level, shows a high level overview with the base of system controllers. Each controller has a unique color and the nodes connected with an indication about the direction as well as the number of dependencies per node. On the second one, the service level shows the system from the perspective of services bases such that the node represents services and the nodes with the same color belongs to the same controller. Finally, function level visualizer communication UML diagram. It dives deeper to demonstrate the service internal functions, the communication flow. We already have some filtration injected in the concept that's emphasizing the user-centric view. So we will find the node filter shows only one node with its dependencies. As an example here, S1 service is shown, and the other filter is path filter. It highlights a specific path in the view. As an example here, S2, S1, S4, and S6. This helps the practitioner to reduce the search space. This filtration also helps in traceability and debugging to apply different filter based on the dynamic behavior, such as path hits that weights paths according to the number of requests get through them. This visualization method as well provides simulation, which is visualize a live simulation for these path execution to highlight failures either in the path or in the service. This failure supports two different simulation data sources. The first is through providing mocking data for the initial service in that path, and the second one is providing a tracing log file that enables automated path detection and simulation. So now we are going to evaluate this design using 7 criteria, starting with scalability, which is supported through the three-dimensional visualization using AR space that offers better scaling with the number of services than a two-dimensional rendering space. Secondly, comprehensibility is achieved in supporting multiple levels of detail to provide an overview of all the corresponding components. And the collaboration has been demonstrated by using a mobile-based solution that provides portability and interaction between users in different contexts, as well as the interaction of services shows the services behavior in different paths as well. And for the navigation adherence, which is supported through the deployment of device standard navigation methods, in addition to the zoom and dragging and clickable elements that we have mentioned. And for the debugging and traceability, which are achieved through the multiple matrices of dynamic behavior filtration, in addition to path simulation techniques for such investigation tasks. And finally, the context awareness is demonstrated such that the view is rendered corresponding to the current user context. And also, we have provided a proof of concept, which we used a prototype demonstration and a research study as well. We conducted a pilot research study with 6 graduate student volunteers. We prepared a set of 9 evaluation tasks relating to this system. We also prepared the 5 question satisfaction survey using a 5-point Likert scale. For the evaluation of the study, we will find that all the participants completed the evaluation tasks with a range of 93 to 96% of accuracy, as well as all participants mentioned the 3D graph visualization was useful. In addition to 5 out of the 6 participants said the representation and the rendering space were very useful and clear to proceed. There were two features requests commonly reported in the final feedback questions, which were the ability to resize and move the graph components. However, these features and more are already listed in the proposed concept, which emphasize the idea that it shows viable and demanding features in practical wise. We'll find this paper contributes to the development of a novel visualization concept for microservice-based systems using AR techniques, which considers the static and dynamic behavior at the same time to be visualized clearly for the practitioners. And based on the primary study, the results suggested that this method is a viable platform for visualizing and analyzing microservice systems. This approach is still open for facing more challenges and supporting more features. We will find something like analyzing the system for discovering and predicting architecture degradation tasks could take advantage of this visualization to annotate and highlight these different architecture vulnerabilities over the visualization of the architecture itself. Moreover, this concept has the potential to be preferred way for producing a complete 3D modeling for microservice-based systems. Thank you so much for listening and attention. Thank you.